So real quick, we're going to go ahead and look at this table. This is taken from your book, so this should be nothing new. I don't know if you necessarily need to write it down so much as you just need to pay attention. But it says, let p of x be a polynomial function. Then the following statements are equivalent. First of all, c is a 0 of p of x. C is also a root or a solution. So zeros, roots, and solutions are all kind of synonymous. Okay, x minus c is a factor. And if c is a real number, then c, comma, 0 is an x-intercept. So basically, zeros, roots, solutions, factors, and x-intercepts, all the same thing. Okay, so it says consider the polynomial function this. Okay, the zeros of this function, as you can see in the graph, are -3, -2, 1, and 2. Okay, they're also the roots, they're also the factors, and the intercepts, or the x-intercepts. So real quick, we're going to talk about the fundamental theorem of algebra. Some people think that this is like the most important theorem of all math. Okay, I'm not one of those. But it says every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. Okay, so basically they're saying if a polynomial equation has a degree greater than 0, okay, it's got at least one root. Okay, so let's go ahead and look at this. It says solve each equation, state the number and type of roots. So we have to solve that. How would we solve it? What?
1 times 9.
Yep, 1 times 9. And then notice since the x squared has a 1 in front of it, remember I can just jump right here to the factors. What's the first term in each of these factors? X. I'm looking for 2 factors of 9 that add up to 6. 3 and 3, both are? Okay. Now if I solve that, what are my solutions going to be? -3 and -3. We actually call, in this case, -3 a double root.
Why is it -3?
Because it's always the opposite. Because it's actually x plus 3 equals 0. And you solve that and you get -3. But since they're like x plus 3 and x plus 3, we actually call that a double root. And if I would have had like this, x plus 3, x plus 3, x plus 3, we would have called that a triple root. Okay. So anyway, let's look at this next one. X cubed plus 25x equals 0. We need to find the zeros. So what are you going to do? What? Take on x. Very good. So, right on track. So x times x squared plus 25 equals 0. So I've got 2 quantities. The first quantity is going to be either x equals 0 or x squared plus 25 equals 0. Does everybody understand where those came from? Okay. Done. That's one solution. Now I got to solve this. So what does x squared equal? -25. What do you do now? Take the square root. Square root, I need to take both the positive and the negative. So, plus and minus. What's the square root of 25, guys? 5i for the negative. And there you go. So, you can have those. Those are actually complex roots. And these we call imaginary roots. Okay, so when we have an I, we call those imaginary roots. Okay, let's go and look at this one. X cubed minus 64 equals 0. So what is this? The cubes? Yep. X and what?
-4.
X and 4. And then what do I do now?
Square.
X squared and 16. So remember, we start with one small quantity, one bigger quantity.
How'd you get the 4 and 16?
Because the 4 is the cube root of 64. 4 times 4 times 4. And then the 16 is the square of 4. So then the first quantity, remember we use what row?
AB.
Yep, the first numbers. So I'm going to go ahead and use the x and the 4. What's the sign I'm going to put between them? Minus, because it is minus in the original problem. What's my next term here? X squared, what sign?
Plus
4x plus 16. Good. So according to this, I know that either x minus 4 equals 0, or x squared plus 4x plus 16 equals 0. So first solution, what do I get here? 4. Good. So we got that one done. Now this next solution, you aren't going to be able to factor this. So then I have to think about what's another way I could solve this. If you can't factor it, what's another way? Quadratic formula. Okay? So negative 4 plus or minus square root of
16.
b squared minus 4ac all over 2a.
What's the formula?
Okay, negative b plus or minus the square root of b squared minus 4ac all over 2a. So then now what's 4 squared? 16 minus, okay, so really I have negative 4 plus or minus the square root of 48 over 2. So now you need to break down 48 and we need to simplify that. Okay, so let's go ahead and break down 48. We know that 48 is 16 and 3. 16 is 4 and 4. So I can actually stop right there and just take out a pair of 4s. Okay. So negative 4 plus or minus 4 root 3i all over 2. Last but not least, what can you do? And we're about done. Cancel out a what? 2. So 2 goes into negative 4, negative 2. 2 goes into 4 2 times. So your answer is actually negative 2 plus or minus 2 root 3i. Okay, so that was probably a little more in depth, but you're going to have to do that on your homework. Okay, sorry. The last few slides we're going to talk about is the complex conjugates theorem, and then we're going to have 2 problems. Okay, so it'll be a little longer lesson today just since I'm not going to be here Monday. All right, so first of all, notice what it says. It says a polynomial equation of degree n has exactly n roots in the set of complex numbers, including repeated roots. So basically what they're saying is if this is x cubed, you're going to have 3 roots. Okay, if x to the 4th is your highest power, you're going to have 4, and if x to the 5th is your highest power, you're going to have 5. So if you remember that first example, it was x squared, and we just had 1 root, but it was repeated. We called that a double root. Okay, and so that's what they're saying. Here, complex conjugates theorem basically states if a plus bi is a0, then the conjugate a minus bi is also a0. You need to understand a plus bi, a minus bi, they're buddies. If one is in the equation, then the other one has to be. Okay? So, if one is in the equation, the other one has to be. So the last 2 problems we're going to look at are as follows. It says write a polynomial function of least degree, which basically means the smallest, with integral coefficients, which means integers, no fractions, no decimals, the zeros of which include negative 1 and 5 minus I. So according to that theorem, what must another 0 be? 5 plus I, the conjugate. So in this case, I have 3 zeros, right? 1, 2, 3. So what's my highest power going to be? 3, right? So now I have to figure out what it's going to be. So this is where things get interesting. Okay, there's your first 0. There's your next one. And there's your third one. Okay. Our task, all right, our task is going to be to multiply all those out. Okay. Now I'm going to tell you right now, what we're going to do is we're going to do the two weird roots first. Okay. We're going to do the two weird roots first. Get ready because this gets long. I'm going to warn you.
Is it hard?
Okay. It's not hard so much as it's long.
That's what makes it hard.
Okay. Now when I say long, I mean literally long in this sense, not long in the problem. It's long this way. Because I have to multiply those two together. Okay, so notice what I did is I distributed that negative. Okay, you always do x minus with whatever the root is. So let's start. I'm going to take x times x, which is what? X squared. I'm going to now take x times negative 5. And I get negative 5x. I'm going to take x times negative I. And I get negative ix. So all I did is distribute the x to each of the terms in the second set of parentheses. Now I'm going to start with the negative 5. So I'm going to take negative 5 times what? X, and I get negative 5x. I'm going to take negative 5 times negative 5, which is? I'm going to take negative 5 times negative I, which is? Now I'm going to do the same thing with I. So I times x. I times negative 5. And then I times negative I. Negative I squared. So that is what those two multiply to be. Notice here I still have my x plus 1. If you're wondering where the plus came from, the two negatives make a positive. So this is the thing. All of your terms with I should drop out. So we need to look. I see a negative ix here and a positive ix here. They cancel out. What happens to your 5i? Cancel. What is negative I squared? It's minus a negative 1, okay, which is really a plus 1. So let's see what I have. So I have an x squared minus how many x? 10x plus what? 26. Now I have to take that times x plus 1. And then I'm done. Okay. So let's start with the x squared first. X squared times x is x cubed. X squared times 1 is x squared. Okay. Negative 10x times x is negative 10x squared. Negative 10x times 1 is negative 10x. And then 26 times x is 26x. And then 26 times 1 is 26. And we're about done. All we need to do now is add like terms, and they're all next to each other. So your final answer, x cubed, 9x squared, plus 26. There you go. That's your final answer.
So in the beginning, it's always x minus,
Yep.
and then your numbers.
We're going to do another one, just to make sure we have it down. Okay? So here you go. We got one more.
Like this.
Last one today. And we'll call it good. Okay, so first of all, what's another root that I have?
X minus 1 plus 2i.
1 minus 2i. So now I start. My first 0 will be x minus what?
1 plus 2i.
1 plus 2i. My next one will be x minus.
1 minus 2.
My next one will be, okay, now that's what I got to multiply out.
The first part's
The hardest part's what?
figuring out the
Yeah.
order.
Oh, it doesn't matter the order. I always try to keep the two complicated roots first and take care of that, and then add in the third one. So I have x minus 1 minus 2i times x minus 1 plus 2i. So let's start. What's x times x? X squared minus 1x, 2ix, 2xi, same thing. Okay, now I'm going to do the same thing with negative 1. So negative 1 I get negative 1x plus 1 minus 2i. Same thing now with negative 2i plus 4i squared. Okay, so I have all of that, and I'm going to take that times x plus 1. Okay, so first of all, what do you notice drops out? The 2ix's and the i's. And I'm going to show you a trick I do with the I squared. Okay, we've learned that I squared is negative 1. The easy way is I'm going to cross off the I squared and change the sign. And then that takes into account the multiplying by the negative 1. Okay, so just cancel out that I squared, change the sign, because that's like multiplying by negative 1. Right, so really I have x squared, what?
Minus 2x.
Minus 2x, and then plus 5. And we're about done. So what do I get? Plus 1x squared. Yep. Plus. There you go. Good job. So let's go ahead and add like terms together. I get x cubed minus x squared plus 3x plus 5. And there you go. Alrighty, so here you go. Page 363, 18 through 26, the evens, 39, 40, and 42. Okay. Now, you should have some assignments for me.